diagram shows a block of mass 5m kilograms and a particle of mass 2m kilograms connected by a light, inextensible string passing over a smooth pulley. The block is on a horizontal table and the particle hangs freely. The part of the string between the pulley and the block is horizontal. The block slides towards the pulley and the particle descends. In this motion, the friction force between the table and the block is 3/4 mg newtons. Find an expression A for the acceleration of the system, B the tension in the string. So if we draw a force diagram, so putting all the forces on here, we have the weight of this one acting downwards, which is 5 mg newtons. It's normal reaction with the table. We've got the tension in the string, T newtons, and we've got a resistance to the motion of 3/4 mg newtons. On this one, we've got the same tension as here, and we got 2 mg newtons acting downwards. We have an acceleration here going this way and an acceleration for this one, the same acceleration going that way for that one. Right, if we now resolve each one, so we're going to resolve this one horizontally, we're going to have T minus 3/4 mg is equal to the mass, which is 5m, times the acceleration. And for this one, we're going to have 2m, going to resolve vertically, 2mg minus the tension is equal to 2ma, mass times the acceleration. Label that 1 and 2. Simple thing to do is to add these two, because that will remove the tension, because T minus T gives you nothing. So we're going to have 2mg minus 3/4 mg is equal to 7mg, adding. And then if we do 2 minus, the m's will now cancel out. So we do 2 minus 3/4 divided by 7, we're going to get 5/28 times g. 5/28 meters per second squared for the acceleration. In order to answer part B, the tension in the string, all we need to do is take that acceleration and substitute it back into either 1 or 2. I'm going to do into 1, so I've got T minus 3/4 mg is equal to 5m times my acceleration, which is 5g/28. Therefore, T will be 25. 25 goes from 5 times 5, so 25m/28g minus 3/4 mg. Now, obviously, in the exam when you're in a hurry, you could do 25/28 plus 3/4, and then just write mg in your final answer. So that's going to give you that the tension was 23/14 mg newtons. So in this video, we have found an expression for both the acceleration and the tension of a connected object. I hope you've understood, and I thank you very much for watching.